In this video, we will show you how to use ColabSaprot. Let's start from switching to a GPU environment, which is necessary for effective training and prediction. Colab provides several types of GPUs. For free trial, you can use T4 GPU. If you want more powerful performance, you can subscribe to Colab Pro, and then you have access to L4 and A100 GPU. To switch to a GPU environment, please follow the steps shown in the picture. Here we choose to switch to T4 GPU. Then you can connect to a cloud server equipped with a GPU. Now we have successfully connected to a server. We can start to use ColabSaprot. To run ColabSaprot, you only have to click this Run button and wait for the interface initialization. In general, it takes 3 to 8 minutes for the initial installation. Here we skip the installation part. Now that the interface has been loaded, we can begin to use following the instructions. In the main interface, we provide 3 functions: model training, model inference, and model sharing. If you don't know what they mean, you can check here for detailed explanation. Also, we provide 3 global control buttons: go back, refresh, and stop. At any time, you can click these buttons to stop and restart. Next, we will show you how to train your own model using ColabSaprot. To start training, you just need to complete some basic setup. First, you will choose the training task type. ColabSaprot supports multiple training tasks. If you don't know how to choose your training task, you can check the red note to get explanation of the task type to help you make choice. After you choose the task type, you need to choose the base model for training. The choice of model can be very flexible. You can directly use official Saprot model, or you can load trained models from SaprotHub for further training. And you can load models saved in your computer to resume training. Here are the tips. If you have no special requirements, just choose official Saprot. If there is a model stored on SaprotHub that predicts the protein property you are interested, you can load the model from SaprotHub and further train it to improve the accuracy. If you have already trained a model and you want to continually train it, you can choose the option trained by yourself on ColabSaprot or saved in your local computer. After the model selection, you need to upload the training data. You can either load dataset from SaprotHub or upload it manually. When you upload your own data, you can choose to upload protein sequences or structures. Please strictly follow the depicted format when you upload your file. Now, we upload a sequence data file as an example. Now, you only need one more step to start training. Here you can set your training hyperparameters. If you don't know what they mean, you can check here for detailed explanation. We also provide advanced hyperparameters for users who want more fine-grained control over the training. Finally, by clicking the button, the training will be started, and the training process will be dynamically updated for users to track. When the training is over, the model weights will be automatically downloaded to your local computer. You can also click the download button to manually download it. The model weights can be later used for property prediction. Next, we will show you how to use ColabSaprot to make predictions. ColabSaprot supports multiple prediction tasks, and we will show you how to use them one by one. Let's try the first section, protein property prediction. This section enables property prediction using well-trained models for various protein characteristics, including stability, subcellular localization, and solubility, etc. You can leverage either models available in SaprotHub or your previously trained models for predictions. The protein property prediction module is similar to the model training module. You need to first choose the prediction task type. ColabSaprot supports multiple prediction tasks. If you don't know how to choose the prediction task, you can check the red note to get explanation of the task type to help you make choice. After you choose the task type, you need to choose the model for prediction. Please note that the model you choose should be consistent with the task type. For example, if you choose the protein level classification task, the model you choose should also be trained for this task. You can load models either from SaprotHub or from your previous training for predictions. Here we choose to load model from SaprotHub. You can search models using our search engine or directly from SaprotHub. The search engine provides an input box. You can type into the keywords about the models or datasets you are interested. For example, here we input the keyword localization. The search results will be dynamically updated based on the keyword you input. All models and datasets that contain the keyword are listed below, and you can click to check. Here we simply copy the example model ID and paste it into the input box. After the model selection, you need to upload the data for prediction. You can choose to upload protein sequences or structures. Please note that the data type you choose should be consistent with the data on which the model was trained. If your model was previously trained on protein structures, you should only upload protein structures for prediction. If you choose to load model from SaprotHub, you can find an introduction in the model page to know which data type was used to train the model. For models with input type, structure-aware sequence in SaprotHub, protein structure input is required. Also, you can upload a single file or multiple files for prediction. Please strictly follow the depicted format when you upload your file. Now we upload a single structure file as an example. Now you can click the button to start prediction. The program will load the model you choose and predict the properties for the proteins you upload. When the prediction is done, the predicted results will be written to a file and you can click to download it. We can see here the predicted label is 0. If you don't know what is the meaning of this label, you can also check the model page. From the model page, we know that label 0 means that the protein is predicted to be membrane-bound. Now, let's try the second module, mutational effect prediction. By using our advanced protein language model Saprot, it enables you to quickly identify promising mutations to enhance specific protein functions, such as enzyme activity. The mutational effect prediction supports two prediction options, single-site or multi-site mutagenesis and single-site saturation mutagenesis. They are similar except that for the first option you have to specify a mutation manually and the model will output a score to predict whether this mutation is good or not. While for the second option, you don't have to specify mutation manually. The model will predict scores for all single-site mutations given a protein. For example, given a protein with a length of 200, the model will output 200 times 20 scores, each for a single-site mutation. Here we use the first option as our example. To predict mutational effect, you are expected to upload the structure of the original protein. If you only have protein sequence, you can use ColabFold to predict its structure and upload it here. Saprot predicts the mutational effect for a single chain of a protein, so you need to specify which chain to be extracted from the structure for later prediction. Then you can upload your structure and submit it. The program will parse your structure and output the structure and sequence information. Now you can input your mutations for prediction. You can input either single mutation or multiple mutations for prediction. If you have multiple mutations to predict, you can choose the multiple variants option and upload a CSV file containing all the mutations. Here we use single variant as example. We can see for this uploaded structure, its first amino acid is S. If we want to know whether it is good to mutate S in the first position to M, we can simply input the mutation information S1M into the box. Then we can click the button to start prediction. When the prediction is done, you will see the mutation score predicted by Saprot. A positive score means the mutation is better than the wild type from evolution perspective, and the higher the better. If you want to predict the effect of a combination mutation, for example, mutating the first amino acid from S to M and mutating the second amino acid from N to Y, you can concatenate these two mutations by a colon. Next, we will show you how to use ColabSaprot for protein sequence design. The sequence design section enables generation of diverse protein sequences compatible with a given structural backbone. You can input your desired backbone and obtain novel sequences optimized for that scaffold. To do sequence design, you are expected to upload the backbone of the original protein. Saprot predicts sequences for a single chain of a protein, so you need to specify which chain to be extracted from the structure for later sequence design. Then you can upload your structure and submit it. The program will parse your structure and visualize the backbone you upload. Here you can see the 3D shape of your structure. Then you can choose the sampling methodology for sequence design. We're providing two options, argmax and multinomial. For each position, Saprot will predict the probability of every amino acid occurring at this position. Argmax means the model will choose the amino acid with highest probability as its prediction. Multinomial means the model will sample amino acids based on the probability distribution. Here we choose argmax as our example. Then we can click the button to start prediction. When the prediction is done, the predicted sequences will be listed below. You can also click the download button to download these designed sequences. Additionally, you can use ESMFold to evaluate the quality of the predicted sequence. When the prediction is done, the structure predicted by ESMFold will also be visualized, and you can clearly compare the predicted structure with your original backbone. Finally, we will show you how to use ColabSaprot to obtain protein-level embeddings. This module enables extraction of sequence or structure embeddings using either standard Saprot models or custom fine-tuned models for specialized analysis tasks. To generate protein-level embeddings, you need to choose the base model for the generation. For standard Saprot models, you can load Saprot 35 million version or 650 million version for embedding generation. For fine-tuned models, you can load models either from SaprotHub or from your previous training. Here we choose to use the official Saprot 35 million version. After the model selection, you need to upload the data for embedding generation. You can choose to upload protein sequences or structures. Please note that the data type you choose should be consistent with the data on which the model was trained. If your model was previously trained on protein structures, you should only upload protein structures. Saprot was pre-trained on protein structures, so here we should upload protein structures to generate embeddings. You can upload a single structure file or multiple structure files. Here we upload one structure file as an example. When you upload your file and click the Submit button, your file will be saved, and then you can click the button to start embedding generation. When the generation is done, the results will be saved to a zip file, and you can click to download it. You can check here to get detailed explanations for the zip file. After you train your own model, you can easily share it on Hugging Face for public use. To share your model, you first need to input your Hugging Face token for verification. You can follow the instruction to copy your own token. After that, you can choose the train models to upload. ColabSaprot will automatically save your model during a training task, and all trained models will be listed below for uploading. When you decide which model to upload, you can name your model and input some basic descriptions. Finally, you can click the button to upload your model. The program will create a new repository under your account on Hugging Face. Now your model will be publicly available. So we have introduced the basic use of ColabSaprot, including model training, model inference, and model sharing. If you have any question, you can raise an issue on our GitHub repository, and we will address it in time. Thanks for watching.